So let's dive into detail about different components of the web guide. First, we'll start off with guide structures and look at how guide structures are with different types of web guides that we saw. So first and foremost, we have the Unwind web guide structure. In this case, you have a parent role feeding the web into your machine. This role is on a shifting stand or a base supported by linear bearings. An actuator connects the moving stand with the fixed base, and then there's a sensor here that is looking at the position of the web. The main objective of an Unwind web guide is to ensure that the web fed into the process is at the desired location. Because of that, you have a sensor fixed to a machine frame, actually moves in and out of the monitor. It's going to go in and out, and the feedback from the sensor is used to make this Unwind guide move in and out so that it can position at the right location. One thing I wanted to point out is that there is a shifting idler. When I say shifting idler, it means that this idler is attached to this moving base. The main reason why we do that is that if we put a sensor right here, it is not an ideal location just because of the fact that when the diameter of this roller changes, you're going to have the web plane go in and out. And if that happens, that's going to affect your guiding. Typically, you would see a shifting idler. It doesn't have to be one. It can be multiple. It could also be a whole frame with a lot of rollers. We need to put the sensor just downstream of the last shifting idler, and the sensor is fixed to the machine frame so we can guide the web. So those are the main things with an Unwind guide. Now, when we look at Rewind guide, Rewind, even though we call it as a guiding, it's not actually guiding the web, it's chasing the web. The main thing unique about this is that in a rewind system, you have a sensor attached to the rewind frame. All of the things in terms of the carriage, it's exactly the same. You have a sensor that is attached to the rewind stand so that when the rewind moves, the sensor also moves. And then you have a fixed idler. Rewind is not really guiding the web, it's actually chasing the web. And the main reason why we do that is that we need to maintain the relative position of the web and the rewind roll. If we put the sensor on a fixed frame and look at this rewind roll, then we would not know the relative position between those two. That's the main reason why we attach the sensor onto the moving rewind stand. Gives us indirectly the position of the rewind stand, and the objective is to make sure that we move the rewind stand so that the middle of the sensor or the guide point of the sensor matches the location of the web. Like I mentioned, it's not really guiding the web, we are chasing the web so that the rewind roll would be at the right location to get the web bound properly. So just to summarize about these two terminal guides, we can look at what are the things that we need to have a good rewind or unwind guiding system. First of all, in terms of design, we need to make sure that the mechanical structure and rigidity and stiffness are designed properly. We are moving a big mass, and depending upon the type of web, maybe metals, it may be thousands of pounds, multiple thousands of pounds that we are trying to move. And we need to make sure that the structure is rigid enough so that we can avoid any mechanical resonance. The natural frequency of the structure should be at least 3 to 4 times the operating frequency of the control system. The other thing we need to consider, especially with these kind of guides, is that we need to size the actuator properly. When we talk about sizing the actuator, what we are talking about is it should have enough thrust so that it can push the mass, it has enough thrust to overcome the static friction, and provide the desired acceleration to reject the disturbances or errors that may be there. Just like the mechanical structure rigidity, we need to also make sure that the actuator coupling and the actuator stiffness are all counted for. Any play in the actuator coupling is going to reduce the stiffness of the overall system. That's going to destabilize your system. In terms of installation consideration, the main thing that we want to look for in these type of guides is the location of the sensor with respect to the moving stand. Either it's fixed to the machine frame or it's moving with the carriage. That's the main thing. These web guides are simple. That's one of the advantages of these web guides. And these web guides really do not have to take advantage of the normal entry rule because all the rollers are parallel to each other, so there's not going to be any misalignment in them. So there's going to be less amount of stressors on the web. The disadvantages with these kind of web guides, well, first of all, you need a high thrust actuator, especially when you have larger mass to move. And it's not cost effective if you really want good performance from a web guide. If you want to reject a high frequency disturbance, then this might not be a good choice for us.